You are in the meeting now.
Recording in progress.
Everything was started on my assignment wrong. I did the notes. Or not assignment wrong, assignment stuff.
All right. Good morning, everybody. So I can tell someone's microphone is on. I would double check it. Microphones. Thank you. All right. Welcome to Wednesday's class. Hope everybody enjoyed their day off on Monday. I know I needed it. Um, and here we are in week 2. Um, So, a couple of things. Here's what we're going to do today. I'm going to go over quiz 1 real quickly. I'm not going to spend a whole lot of time going over quiz 1. The grades for quiz 1 should be posted in Blackboard. And they are. So, again, I'm not going to looking through the grades. Most of the grades are really good, so I'm not going to spend a whole lot of time going over quiz 1. You're probably wondering, what about week 1 homework and notes? Well, let me just say this. First of all, I had a terrible Saturday and Sunday. I did not feel good at all on Saturday and Sunday, and one of my kids has been sick, so we're not getting much sleep. We have a newborn. Well, she's a month old, so I guess she's technically not a newborn, but we're not getting much sleep, so I just didn't do any work this weekend. So I just needed that long weekend to rest. So I just haven't gotten to the notes and homework yet, but I will as soon as I get opportunities to, and you'll see those grades start popping up. So we're going to just really quickly just look at the quiz. I will post the key to the quiz in Blackboard. And then we'll spend the rest of the class addressing questions over, I believe it's going to be assignments 3 and 4, dealing with linear applications and complex numbers. So let's transition and just start looking at that quiz. Again, I will post this key up in Blackboard as soon as I get a chance to. As I recall from grading, there wasn't too much issue with problems 1 and 2. I will say this, because this is one of the, I'm not saying this is a mistake in this class, but one of the most common mistakes I see within solving any type of equation is, for example, right here, that -4, that negative has to carry with the 4 into the 3 and into that -5x, thus making it a positive 20x, because a negative times a negative is positive. That's one of the most common mistakes I see. Problem number 3, there was some issues with problem number 3. The answer is no solution, and the reason that you get no solution is you end up with a -5x on both the left and the right, and when you try to combine your x's together, they cancel out, and so you end up with this false statement leading to conclusion of no solution. So some of the errors I saw were things like not canceling out the 5x's or making that a negative 10x for some reason. That was one of the issues I had with that. The problem number 4, make sure that you're using that LCD to make the fractions go away, to clear the equation of fractions. So, for example, right here when we have 20 over 1 times x over 5, the 20 gets divided by the 5, thus making it a 4, so then you have 4 times x. And on problem number 5, your LCD is 15. Make sure to distribute that 15 to all the terms of the equation, so even to that 3. And when you take 15 and divide it by 5, that gives you 3. Make sure to take that 3 and distribute it to the x and to the 2. Some of the errors I saw were not distributing that to all the terms. When I go through and grade in what is called Gradescope, I am making annotations along the way. So I'm going to switch to we're going to take a look at Blackboard real quickly. Hopefully we can see this work out. So when you log into Blackboard, and you look at My Grades, all right. So this is going to look a little bit differently because I didn't do it for myself. When you look at the week 1 quiz, because that's the last thing that we just did, you should have some sort of icon right there, a clickable link. I really should have created my quiz for myself so that you could see this. You should have had some sort of icon or a link right here, or maybe it's over here where it says your grade, and you can click that link and it will take you into Gradescope, or take you to a it'll take you to your quiz where you can get a report that if I made any sort of comments on your quiz, you can see those comments. And so be sure to explore that. Like I said, I really should have graded a quiz for myself and walked y'all through this. I just did not think about doing that. So if you're having trouble looking at that, we'll try to remember to do that on Friday so that you can see, oh, these are the comments that he made on my quiz. I will circle errors, problems in your work that say, oh, I should have done that instead. So anyways, let's transition now to addressing any questions that you have over assignments 3 and 4. Do we have any questions over assignments 3 and 4?
$22 on assignment 3, please.
22 on assignment 3. 22, we have a 2x minus 1 over x minus 6 over an x plus 3 is equal to 2x squared minus 1 over a x squared plus 3x. Okay, so this is aligned with assignment 2 dealing with rational equations. It's of the same category. So what we want to do is we want to make the fractions go away, and the way that we do that is we multiply through by the LCD. And just like all those problems in assignment 2, especially the latter problems in assignment 2, if you take this polynomial, let me ask you a question, can you factor it? Can you factor that polynomial? Anybody?
Yes.
Yes.
What is the factored form? What is
X
the factored
parentheses X plus 3.
Yeah, there's a GCF of x in this polynomial. So when you factor it, you get x times the x plus 3. Alright, so to the student who asked this question, did you factor that part of the polynomial? To the student who did ask the question, did you do that?
No.
Alright, now, let me ask you a question now. Do you see what you need to do now?
Yes.
Okay. Do we want to look at it together? Do we want to continue?
Yes, please.
Okay. Here is your LCD. These come in the denominator. So, to save some time, we're just going to multiply this whole entire equation. I'm going to write it out like this. And this LCD is going to distribute to all three terms. So, when we distribute the LCD of x times x plus 3 to this first term, the x's up, think about this as on top, and this x is down below. The x's are going to cancel out, leaving you with x plus 3 times 2x minus 1. Minus, then when you distribute the LCD to this term, the x plus 3's will cancel out, leaving you with x times 6 equals, now the factored form of this is the LCD, so when you distribute the LCD to this third term, the top cancels out with the bottom, leaving you with a 2x squared minus 1. Now, excuse me, you look at this and you might be saying, well, wait a minute, this isn't linear, this is quadratic, and we haven't talked about quadratic equations yet. And you're right, we haven't talked about quadratic equations, but something is going to happen to make this linear. What we have to do next is we have to go through and FOIL. X times 2x squared, or 2x is a 2x squared. X times negative 1 is a negative x. 3 times 2x is a 6x. 3 times negative 1 is negative 3. Then we have minus 6x is equal to 2x squared minus 1. And so when solving an equation and you're thinking about moving terms, if you have the same term on both sides of the equation, well, they cancel each other out. Because if you subtract 2x squared over here to over here, cancel out. So let's just mark those out. And you know what I see? I see a positive 6x and a negative 6x on the same side of the equation. So I can mark those out. So that leaves me with negative x minus 3 is equal to negative 1. Add 3 to both sides, that gives me 2, which then means x is equal to 2. Now before I circle that, because I'm just thinking about this, I'm looking back up here at this polynomial, and I'm thinking, alright, I could check it by plugging it in, and you could do that on your own, but what I want to know is, does that contradict with what x cannot be? So remember, with rational equations, one of the things that we always have to ask ourselves is, x cannot equal what values? What values can x not equal? And in this problem, x cannot equal 0, because if you had 0 right here in your denominator, anything divided by 0 is undefined. Okay? And x cannot equal negative 3, because if you had negative 3 plus 3, that's 0. 6 over 0 is undefined. So no matter what, your x can't be 0 and it can't be negative 3. Well, that doesn't contradict with the 2, so I might do one last thing. I might just take a look at the enter key to this, and I haven't looked at the enter key yet, but does that align with the enter key? Negative 4. Alright, what happened? What went wrong?
It's x equals negative 2.
The 1 should be a positive.
Alright, why, did I write down the problem wrong? Yeah, I wrote down the problem wrong. I wrote down the problem wrong. Thank you for pointing that out. That should be a plus 1. So that's a plus 1. Got to write down the problem correctly. So you have negative x minus 3 is equal to positive 1. So that means that you have negative x is equal to a negative 4, which then means that x is equal to 4. There we go. Make sure that you write down the problem correctly. Alright, to the young lady that asked about problem number 22, does it make sense how to approach this problem now? Alright, got a thumbs up. Alright, what else can we look at?
Shouldn't the answer be negative 4?
And can you say it one more time, please?
Shouldn't the answer be negative 4?
No. Wait, what am I doing wrong? Oh, man. There we go. Alright. Thank you. There we go. Alright, any other questions?
Can we do number 23?
Same assignment?
Yes, sir.
X minus 1 over a 2x minus 1 minus x over x plus 1 equals a negative x squared plus 2 over a 2x squared plus x minus 1. Alright, so at this point we know that we need to factor this guy right down here. I'm going to take an opportunity here to just show you two ways in which I factor. The first method that I factor, and this is usually my go-to method, is just trial and error. And I think about the factored form. First of all, I'm not going to assume that the factored form is this. Do not make that assumption. It's not always true that the factored form is the product of these two guys. But rather, I'm just going to think through this. I know that this term times this term has to be 2x squared. Well, the only things that multiply together to give me 2 are 2 and 1. So I got to have an x and an x right there. Alright? Then, I look at this guy. This term times this term has to give me negative 1. So I need a negative 1 and a positive 1. So I know I need 1 and 1. So the next matter is deciding where my signs go. So I'm going to look at now at my middle term. That has to be a positive 1x. So if I take 2x and make it positive by putting a plus 1 right there, so 2x times positive 1 is 2x, then I know that this has to be minus, and I'll just double check. 2x times x is a 2x squared. 2x times 1 is 2x. Combined with a negative 1 times 1x is a negative 1x. So that gives you your positive x. And then you got minus 1. That's one way I do it. The other way that I do it is, and this is especially useful for more complicated trinomials. For the moment, I'm just going to ignore the 2. Well, before I ignore the 2, I'm going to ask the question, what are the factors of AC that sum to B? So A times C, 2 times negative 1 is a negative 2. That sums, so the factors of AC are negative 2. That sum to B are negative 1. So the things that multiply together to give me negative 2, but add together to give me negative 1, or B is positive 1, excuse me, is going to be a negative 1 and a positive 2. So here's a cool little trick. I'm going to put x and x, negative 1, and then positive 2. And now what I'm going to do is I'm going to divide by the 2 that was in front of the x squared, my leading coefficient. Now, let's look at what we can do here. In this second set of parentheses, 2 divided by 2 becomes 1. Now, we don't want fractions, so 1 divided by 2 becomes a fraction. So instead of writing it as a fraction, what I'm going to do is I'm just going to take that 2 and bring it up in front. And you get 2x minus 1. Exactly what we have up here. Alright. All that to say, if you just take a look at this, oh, it is my LCD, is the product of my other two parentheses. So we're going to go and take this, and we're going to distribute it to 1, 2, 3 terms. Here we go. If you take the LCD and distribute it to the first term, the 2x minus 1's cancel out, leaving you with x plus 1 times an x minus 1 minus When you distribute the LCD to the second term, the x plus 1's cancel out, so that's going to be minus x times a 2x plus minus 1. When you distribute the LCD to the third term, bottom part cancels out. You're left with negative x squared plus 2. And I imagine the same thing's going to happen here as in the last problem. FOIL, so you get x squared, the x is going to cancel out, so x squared minus 1. Distribute the negative with the x, so that's going to be a minus 2x squared plus x is equal to negative x squared plus 2. On the left, combine your like terms together, so 1x squared minus 2x squared is a negative 1x squared. Then you have plus x minus 1 is equal to negative x squared plus 2. So that means the minus x squared cancel out. We will add 1 to both sides, so that gives you x is equal to 3. Does that make sense? Kind of plow through that problem. Were you able to follow along? Okay. What else can we look at? Anything from assignment 3? Or excuse me, assignment 4. Complex numbers. Are y'all just currently working your way through the homework? Is that what we're doing? See some thumbs up. What about Sudan? Yeah, it's Sudan. Y'all's room is so dark. It's hard to see y'all. But I see y'all. Is there 3 of y'all in Sudan? Yeah. If y'all want to work in the dark, that's fine with me. It's just hard to see y'all. But I appreciate turning on the lights. Thank you. Any other questions that I can help you with?
Can we do 17 on assignment
17 on assignment 3. Did I hear that correctly?
3? Yes, sir.
Problem 17. A is equal to 1/2 h times a plus b. And we want to solve for little a. So we want to get little a all by itself. We want to get little a all by itself. So the goal is to isolate him. Okay, so I'm just going to do a little side example. If you had, I don't know, 5 is equal to 10 times an x plus 3. One of the ways to get x by itself, the temptation here for most of us is to distribute that 10 inside the parentheses. But that's not the only way to get rid of parentheses in this particular case. In this particular case, one of the things that we could do is we could divide both sides by 10. And now you have 1/2 is equal to x plus 3. So I just did this little example, something that we're a little bit more familiar with, at least in the format. You don't have to always, and it depends on the particular problem. In this particular problem, you can do it because the 10 in the parentheses is the only thing on the right-hand side. To get rid of that, to get rid of the parentheses, you could just divide both sides by 10. So we can do the same thing here in this problem. To start getting rid of those parentheses, what we could do is I could just go through and divide both sides by 1/2 h. And so now what you have is a over a 1/2 h is equal to a plus b. Alright, now to get a by itself, you're one step away from getting a by itself. All you gotta do is just subtract b on both sides. But there's a problem that I have with the format in which I wrote this. Never, ever, ever leave your answer where you have a fraction bar and you have either a fraction in the numerator or in the denominator. This is what we call a complex fraction. You have a fraction bar here, but either in the numerator or in the denominator we have another fraction. So one of the tricks that you could do to get rid of the fraction down below is you can multiply the top and the bottom by 2. And so what does that do? Well, first of all, just look down here down below. Think of that 2 as a 2 over 1. Those cancel out. The other thought process that you might say is, oh, I'm just going to bring that 1/2 up to the numerator, but do its reciprocal. And this all leads you to the fact that you now have 2 big A over H is equal to A plus B. Now to get little a all by itself, all you got to do is just go through and subtract by b on both sides, and we get the following. 2 big A over H minus B is equal to little a. Does that make sense?
I actually have a question.
Sure.
So when you multiply by 2, you get rid of the fraction. Are you not supposed to do that to the other side?
So when I'm multiplying, so I'm just going to come back here and just write what I just did. So you have A over 1/2 H. So you're asked the question, when I multiplied by 2 to get rid of the fraction, what was that last part that you said?
Are we not supposed to multiply by 2 to the other side also?
So the reason that multiplying by 2 over 2 here works is because 2 over 2 is equal to 1. So all I'm doing over here on the left hand side is multiplying by 1. If I was multiplying by any other value, let's say multiplying by 4, yes, I would have to multiply both sides by 4. But all I'm doing is multiplying by 1. So the left-hand side is not changing in value. All that's happening is just multiplying by 1. And I'm just using this thought down below. Oops, I don't know what happened there. I'm just basically focusing my thought process now right in here. And I'm just looking at this as 2 times a half. Well, 2 halves is 1, so this just ends up being the 1 and then tack on the h down here. So that's how I'm getting rid of the 1/2 down below. Does that make sense? Did I answer your question?
Yes, you did. Thank you.
Just to carry your thought on a little bit further, this is just this may be unnecessary, but we have a over 1/2 h is equal to a plus b. So if you multiply both sides by 2 over 2, well, remember what we're doing here. Those cancel out. So you're left with 2a is equal to, now what I would do is I'd realize that, 2 over 2 is 1. So you just have a plus b times 1, which doesn't do anything. Alright. I hope that addressed your question. What else can we look at? Have we started assignment 4 yet? Yeah, no. Oh, no. Alright, so, if you haven't started assignment 4, just be aware of, what's, happening on the remainder of this week. So, if you look at our assignments, we had linear equations. You probably need to see what I'm writing. We had linear equations, and we've taken a quiz over linear equations. Last Friday, I addressed questions over rational equations. So that's next in line, so that's done. So we got rational equations. Today, if you look at the calendar, today has been all about answering questions over linear applications and complex numbers. That was on the calendar for today. Which means that all 3 of these are up for a quiz that will happen on Friday. You will get a quiz that will contain questions potentially from all 3 of these assignments on Friday. And then what we talk about on Friday we're going to talk about quadratic equations. We're going to answer your questions on Friday. And that will be covered on quiz 3. So I say this to emphasize what you got to stay on top of. So I hope that you find assignment 4 very successful and doable, because there will be a quiz over, problems from assignment 4 on Friday. Anyways, just a reminder. All right, back to your opportunity to ask questions. Anybody have any more questions that they want to go over?
Can you go over 21 on assignment 4?
21 on assignment 4. 21 on assignment 4. So let me pull up assignment 4. Let's look at 21. Okay. Assignment 4, problem 21. We have -8 plus the square root of a -36 all over 24. So, in assignment 4, we learned that the square root of a negative integer, so that's a b, by the way, that's a b. The square root of a negative integer is I times the square root of that integer. And this all is going back to the complex number I is equal to the square root of -1, and we also have this other property that I squared is equal to -1. If I didn't, well, we'll use this concept right here to help explain why the square root of -1 is I. It's by definition. So when I look at the square root of -36, first of all, I'm just going to go ahead and say it. This becomes square root of 36 is 6, but because it's a negative, we have a 6i over 24. Now, here's just a little bit of math. I want to show you some math about what's going on behind the scenes. Square root of -36 is equivalent to the square root of -1 times 36, which whenever you have a product inside your radical, you can split the radical. So I just split the radical. So we have the square root of -1 times the square root of 36. By definition, the square root of -1 is I, so that gives us I times the square root of 36 is 6, and just for formality's sake, we'll write that as 6i. So square root of -36 is a 6i. Now what you want to do is you want to simplify this. So one of the ways in which we simplify this is I'm going to first of all split my fraction bar. So you have -8 over 24 plus 6i over 24. And we should not have a problem with this because just work backwards. Can we combine these two fractions together? Yes. Why can we combine these two fractions together? Because they have the same denominator. And we know that when you add fractions together, you add the numerators together and you put it all over that common denominator. So if you just, this is just a, call it, this thought process goes around and around. You can take this, take it back up here, which means you can take this expression and rewrite it as the combination of two fractions. Now we can continue to simplify. Well, -8 over 24 comes out to be a -1/3. 6 over 24 is 1/4, and we'll tack on the I. And there is our final answer. Now, when expressing your answer with complex numbers, your answer format should always be of the form A plus BI. Now, or it could be A minus BI, or it could be a -A plus BI or a -A minus BI. But it always has to be the format where you have a real number combined with the imaginary number. That's the answer format every single time you give you do have a complex operation. And anyways, there's our final answer. So I want to point something out here. One of the common responses I get here is when we have that negative 8 plus 6i over 24. One of the common things I see people do is they'll say, oh, they're all even. 8, 6, and 24 are all even, so I can say, oh, this is negative 4 plus 3i over 12. And you tell me that's the final answer. Well, no. Why not? Because it's not of the form a plus bi. No, don't give me this as the answer. Don't tell me this is the answer, because it's not of the form a plus bi. You have to take it to the fullest final step where you have a real number combined with an imaginary number. Alright, so to the student that asked about this question, does it make sense?
Yes, sir.
Okay. Question, what did you have, where was your hiccup, just out of curiosity?
In simplifying?
That's simplifying. I was 95% sure. Either not simplifying this, or you took it to right here. We're so used to taking it to this step right here because this is kind of what we do with solving quadratic equations. This looks like the one of the results of what you get when you have a quadratic equation. You have something plus a square root all over something, and if you can't simplify, you kind of are left with this statement right here. Well, that's great for quadratic equations, but we're dealing with a complex expression. So always bring your complex expression to the final form of a plus bi. Alright, what else can we look at? Anybody?
You go over 20 on assignment 4.
20 on assignment 4. Love to. Problem number 20. Negative 3 minus the square root of negative 7 squared. Okay, I'm going to show you two ways to look at this problem. Both of these methods, first of all, begin by recognizing that, oh, this means that we have repeated multiplication. Okay? Now, I'm going to put a comma. The other way to look at this very same expression is to go ahead and take, in fact, let's just carry on through this. One way to look at this problem is to go ahead and take care of simplifying these square roots of a negative number. Now, 7 is not a perfect square. You can't simplify it. So all I'm going to do is essentially, you could say, oh, I'm taking the negative out and replacing it with an I. I mean, that could be a simple way to say it. Now you got to go through and FOIL. Alright, so bear with me. Negative 3 times negative 3 is a positive 9. Negative 3 times this negative I squared to 7. Well, negative times a negative is going to be positive, so that's going to be a positive 3I squared to 7. And you're going to get the same thing over here, because negative 3 times a negative is going to be a positive 3I squared to 7. And then you got to take your last terms. A negative times a negative is going to be positive. I times I is I squared. And
Your conference is scheduled to end in 2 minutes.
Thank you for letting me know. One of the tricks or algebraic things that you need to remember is if you have the square root of a times the square root of a, that's equal to the square root of a squared, which the radical and the exponent of 2 cancel out, gives you just a. So the square root of 7 times the square root of 7 is just 7. So that's an I squared times 7. Now, there's a lot of simplifying that's about to happen. 9. Now, these two things are like terms. They both have the I squared of 7. So we'll combine the coefficients. And over here, we have to go back and recall our definition for I squared. What is our definition for I squared? I squared is equal to negative 1. So this technically means you have negative 1 times 7, which is now negative 7. Which now we can combine our constants together. 9 minus 7 is going to be 2 plus the 6I squared to 7. And that's how we arrive at our final answer. The other way, well, I don't know if I'm going to have time to do this. We'll try. The other way to look at this is when you go through and FOIL, negative 3 times negative 3 is 9. Negative 3 times the square root of 7 is going to be a positive 3 square root of 7. Positive 3
Your
times
conference is now over. Goodbye.
Anyways, don't have time. Y'all have a wonderful rest of your day. I'll see y'all on Friday.